All right, when we look at a problem like this, we're given a chemical reaction, and the question is giving us the enthalpy change. That's an endothermic reaction, so we could rewrite that reaction with this value on the left. That's the format for an endothermic reaction. That means that amount of heat is absorbed. And it asks for grams of ammonia. And so there's our ammonia. This is what we're looking for. Can be produced if that much heat energy is provided. Now, the reaction with this stoichiometry takes that amount of heat energy, but we're saying let's only give it 61.5 kilojoules of heat. So we're giving it more, actually, than it needs for this stoichiometry. 46.72 kilojoules will produce 4 moles of ammonia. We want to know how much ammonia if we give it this many kilojoules, the 61.5 kilojoules of ammonia. Now, we don't want to just know moles, we want to know grams. So we worked a couple problems where you determine moles in this format. Now we're just asking you to take it one more step to grams. Fortunately, you've done a bazillion grams to moles problems, so once we have moles, we'll know how to take it to grams. So the first step is to determine how many moles of ammonia. Then once we've got that answer, we can take it to grams. We can do that in 2 steps, or we can do it in 1 step. I usually just do it in 1 step using the factor label method, using the conversion, the unit conversion method. So I want to know how many grams of NH3 equals 61.5 kilojoules of heat. That's what's given, the 65 kilojoules. This is what I'm trying to find, how many grams. And then I will multiply by a conversion factor where I put that kilojoules in the bottom so that it can cancel. I need an equivalence for that kilojoules. So the equivalence is a kilojoules to moles based on the stoichiometry of that reaction. And there are 46.72 kilojoules for every 4 moles of ammonia. I'm going to moles of ammonia because I want to find grams of ammonia. That way my kilojoules cancels. And now I need one more conversion where I take that moles, again, writing my units first so that it cancels. I'm looking for grams of ammonia, so grams will go on top. And this is my grams to moles. That is the equivalence we learned using the molar mass, the molecular mass, the formula mass. I just said the same thing 3 times. So I would look up NH3 and determine its molar mass. I happen to know these numbers off the top of my head, but I don't know them all. Nitrogen is 4.01 and hydrogen is 1.01, and there are 3 of them. So come to my calculator, 14.01 plus 1.01 times 3. So he's 17.04. So that's 17.04 grams of ammonia for every 1 mole of ammonia. And now I'm ready to calculate this. So I've got 61.5, that's my starting number, times 4 divided by 46.72 times 17.04 equals, and I get 89.722 grams. It looks like I'm going to go down to 3 significant figures based on that first number that I'm given. So how about 89.7 grams of ammonia? That's what I'm going to type in for the answer. When you pull up this problem on your homework, the numbers may not be exactly the same, but the method is exactly the same.